Thank you. So I am Scott Southworth. You can find me at Dark Marmot on GitHub. And I got to, I guess, use Elixir for the first time when I basically weaseled my way onto Brian Hunter's team at HCA and learned it just to do Waterpark. So if you think you can't do distributed systems, you should just realize that I started out not knowing anything about it, and it's still running, so that's kind of nice. So my talk is about using Lua in Elixir. And I guess a lot of people would be like, why are we talking about Lua at an Elixir conference? And the thing is, Elixir has just a ton of awesome traits, but Lua can do some things it can't, and it gives you some just extra superpowers that you can leverage. And so we're going to go through seeing what it is and why we might want to use it, and then how we can run it in an Elixir project. I've put together an actual repo on GitHub with actual source code you can check out at the end. So our demonstration problem is basically going to be an algorithm that you might have heard about called the traveling salesman. And that's where you have a salesman who wants to visit like a whole bunch of different towns, but he wants to do it in the most optimal route possible so that you don't waste a lot of time and distance. In this, there was kind of an AI competition that I took part in a number of years ago by the company called ScribD. And they put up something called Robot Fruit Hunt. And I've totally ripped it off. And the idea was you'd have two players, and you'd each write an AI for like a little guy. And he would walk around. You basically, every turn, could say, you know, go a cardinal direction or eat something like a fruit. And the fruits had different point values. And so you'd kind of have to weigh, like, where's the other person? Where am I? What route can I take advantage of to maximize my score, minimize theirs? In this one, we'll have two little animals, a boar and a coyote, and we'll create, you know, the brains for each of them and let them fight it out. Which goes back to another thing. I have a tendency to put like little furry animals and references to them in my code, which drives some people absolutely mad, and will be throughout this presentation. So Elixir, as you know, is, you know, just an incredible language, but it also lets you do things that are relatively dangerous. So there might be some Elixir code you wouldn't want to run on your system, that you wouldn't trust running on your system. And so a lot of times we say we take code from an untrusted source, much like SQL injection or something else. Just blindly executing it could be a really bad idea. But with Lua, we could actually be okay. So we've all seen this guy. And he'll come to you, and he'll have tasks for you to do, and he'll want stuff to get done. And you know, it would sometimes be really nice if we could say, here's this, like, you could just write this little script, and it would do everything. But a lot of the scripts and the tools that we use are a little harder to use than what most of society is comfortable just taking advantage of. And so you've probably heard of domain-specific languages. And these are kind of, you know, simplified, specialized languages that solve particular use cases. SQL, super standard for databases, things like that. Everybody, you know, doing business work practically is scripting Excel. You could look at golf as its own language that gets a lot of stuff done. In this instance, we're going to see how can we use something like Lua to give us a lot of flexibility that we can get with a domain-specific language, but do it in a way that still protects our code and our systems. Elixir itself is going to give us some, I guess, some special powers here where we can be protected, say, by preventing things from executing for long periods of time. And we can just spin up processes and kill them if they run too long. And so that's already there out of the box. Now, something that's a little more interesting is that the beam itself has this idea of reductions, which are somewhat analogous to the amount of work that a system is doing. And it's how the virtual machine is tracking a measure of work. And it, as you might have heard earlier, it doles out 2,000 reductions at a time by a scheduler. And so every process lines up, and they each get just this little chunk, and they can do some work, and then they're done. And it's so different than a lot of other systems where you have, instead of what's called preemptive scheduling, as you have here, you have cooperative scheduling, where things have to yield and work with each other. In this instance, we give everyone just a little bit of work, and if we're unhappy, we kill them. So here, I've got this repo set up for this game called Forager. And so this is just part of it that's Elixir. And the idea here is, you can run any function in a worker process, but while it's running, we can watch the reductions. And so if it, in this instance, if it goes over 1 million reductions, I'm killing the process. So you can see it right there returns a result and shows us exactly how much work the VM has basically reported back. The duration's in milliseconds. So what Lua gives us is something, it's a scripting language that's Turing complete. It's really fast, it's really simple, and we can completely lock stuff down. And I guess I've been in a lot of instances where just having something where I can configure with an if statement is really valuable. So the language itself is from Brazil. It was created in 1993, means moon in Portuguese. There's another language that was from Brazil that you guys have probably used. So I felt like it was kind of a natural pairing. The thing is, Lua has been primarily used in the video game industry for most of its history. And a lot of that had to do with the fact that Lua has excellent interop with C, and you could just move data back and forth between them really, really quickly. And with video games, you often would have these giant engines. People would update them, and you'd have like a build time, like, you've got this huge C code base, and you'd wait 24 hours to see if things changed and worked. And that doesn't lend itself to rapid iteration of software development. And you've got all of these artists and these script designers and game designers, and they're all wanting to make changes and test changes. And so you would have the programmers working on the engine, and then you would have all of these ostensibly non-programmers doing a lot of programming for the game, but they're all working in Lua. And the engine itself is exposed to Lua. And that turned out to be a really powerful thing and has been used time and time again. Only recently have visual scripting engines like Blueprints in Unreal started to really replace Lua. Another thing that it's been used at, which I find just fascinating, is that you've got companies like Roblox that, if you've got kids, you know Roblox. It's basically the YouTube of video games where little kids can make Minecraft-like games and share them with each other in multiplayer environments online. And Roblox exposes all of this functionality through Lua. So a lot of kids would learn how to code Lua, and then they'd get in and they'd upload all of this dynamic content. And so Roblox is running tons of code written by kids who are pretty much like trolls and somehow keeping their servers up, right? And I found that just to be, that's amazing to me, because usually the idea of just running some random kid's code and being like, yeah, our servers will be awesome. It's like, I mean, we can usually not even get our own code to make our servers awesome. If you've heard of Robert Verding, one of the guys who created Erlang, he also has created things like Lisp-flavored Erlang and Lua in Erlang, or LuErl, which is an Erlang library that you can pull down from Hex and use. And what's amazing to me about this is LuErl, you can see right here, you can just call luerl.init. That returns just a data structure, an immutable data structure that is roughly 13 kilobytes in size. And it's an entire virtual machine. That's like the whole state of the whole Lua VM. And we can take that and we can manipulate it and we can pass it around and just load it up with stuff and do things with it. One of those things that we can do is that we can sandbox it. And this is something that Lua has that you won't find in a lot of other languages. We can basically take portions of the Lua VM and just remove them. We can say, there's no more file access, there's no more network access. Brian earlier was saying that math was really cool to have. We can just get rid of math if we want. Just no more math. And that's fine. If you want, you can then say, I'm going to expose math in my code, and maybe let Lua use whatever math I give it, which might not be correct, but you know. So the way Lisp is lots of lists, Lua is just associative arrays. They're called tables, and it's like tables all the way down. It can hold data, functions. When we want to get rid of something, what we're doing is we're deleting the associated table from the VM, and it's just gone. I ended up in this repo getting some help from one of my coworkers, Brian Paxton, to go through and translate Robert Verding's sandboxing of his VM from Erlang to Elixir. And what this is just showing kind of how that works. You just basically list out all of these things you don't want someone to have access to, which could be dangerous, and we're just nulling them out, like recursively. So with Lua, we can embed it within another program. We can then call its functions to update the state of its VM or to just return something. From Elixir, it looks like this. You can see here, I'm just evaluating a function. We pass in the state, which is an entire virtual machine. And it's very performant, even though that sounds insane. And you can see here, when we call the function, I can get back a result and a state, which would be the updated VM. We don't necessarily have to keep that. In fact, one of the cool things about working in an immutable environment is that a lot of times it's fun to just throw that away. So we can just keep a reference to kind of this pristine, perfect VM not worry about collecting garbage or doing anything like that, and just keep operating against it and passing it around. And in here, to make sure that it doesn't do anything bad, you end up running the function through like a worker process that can limit the amount of processing or memory or time that we want to give it. So there are some gotchas you have to watch out for, mostly because you have to deal with type conversion, because Lua does not have nearly so many types as Elixir. When you throw in a list, it becomes an associative array, which is integer keyed map, kind of, in Elixir. All your atoms go to strings. If you send a Lua table back into Elixir, it's coming back as a list of key value tuples. And Lua can just out of the box normally return multiple values. You can be like, I'm going to return 1, and then you can just change that to, I'm going to return 1, 2. And it's not really a list, it just comes back as a multiple value. That is not fun to deal with in a language like Elixir, where arity is such an important aspect. So I pretty much got rid of that. It can also create cyclic references if you want to do that. Elixir is not going to enjoy a cyclic reference. When you try to unroll it, it doesn't. So also don't try to do that. So the other thing we can do is we can extend Lua. And so we can take functions from Elixir or any containing program, and we can make them available to Lua. Now, that you have to do with care, because at that point you're opening up the can of worms of it can do anything you've told it has access to. So if you give it access to the file system after removing it, you've undone everything you made safe. So here's an example of adding a function. And so right there, we just start basically setting a table in the LuWorld VM, and it has an Elixir function that we're going to run, and that's pretty much all there is to it. Now, once you do that from within Lua, it's just a function of the same name, and you've got access. We'll see that in a minute. The other thing that you can do is we can construct these VMs to get them into the exact state we want before we use them. So if we have a library of code that we want to make available, we can either expose that as Elixir functions, or we can write Lua files or bring in Lua libraries, and we can just build that VM in memory, and then we can just keep reusing it and have it just kind of preloaded with everything we care about. So in the example repo, I've got it set up so that we build everything in both Elixir and in Lua, so you can see both variants. Here, what happens is we pass in a script, which is like, in this example, is a script that would be the AI of one of our little animals that's going to run around grabbing fruit. And then you can end up, say, that add script player.lua is basically a bunch of utility functions that I want my scripts, everybody to have access to. And the random int thing, you'd have to, because random numbers often work off of a seeded value, rather than deal with modifying the VM to change the seed dynamically, I just exposed Elixir/Erlang's random system so that you didn't have to worry about that. And then we add the script at the end that kind of that can take advantage of any of the functions in player.lua, or we could skip the player.lua we could define all of those functions in Elixir, expose them into the VM, and then add a script that gets passed in. And when this happens, we're able to basically parse and compile kind of this chunked Lua VM that we can just run against. If you would like to experiment with Lua online, and this is something that I ended up doing a lot of while I was doing this project, mostly because it's harder to debug Lua in an Elixir environment than it is to debug it in a Lua environment. So they've got things like this interactive online little box. You can just type in everything you want. You can run the Lua and see how it goes. And so this is just a cool tip. That not only for Lua, but if you have external assets that you want to compile into your application, you'll find in the docs for Elixir the mix recompile directive. And you can set it up so that, like, this in particular, the script this is a part of will read through the local my priv directory, look for all the Lua files, and hash them, and then we end up basically comparing on a recompile, it compares the hashes to see if things have changed, and if they have, it'll recompile these in so I can have script access to all of the strings that make up the files, and it's just a really handy way to, if you want to have actual source code that's embedded. So now what we're going to do is I'm going to switch over to a little live view. So in this instance, the boar has an AI that says, go to the nearest little fruit and eat it. Now, the little coyote has an AI that says, go, and for whatever reason in the final column, there's a HTML thing where it changes scale. I don't understand it. But the coyote prioritizes the most valuable, delicious, biggest fruits. Well, let me see if I can do it again. So, okay. So the coyote in this instance is going to go down to the banana, which is it's a high value fruit. But you can also see in the corner, it shows you which of the what command came back from its AI algorithm, which is either a cardinal direction or byte. So I wanted to get a leaderboard up for this, but I didn't have time. I apologize. But that's what scriptd did. And so everyone could have like a big fight, and like you'd get like a chess ranking for your AI. So the way that's working is there's a Lua function that's defined that basically is just move. We pass in like a map that's a view of the game, just tells them like, here are the fruits, and here's the width and the height and the players and their positions. And so every turn it sees its view of the world, and then the AI just returns a direction, or it says bite if it's on a fruit and it wants to eat it, which everything takes a turn. Or it passes if it were to say, use too many reductions to try and figure something out, and we just kill it. So this is what the Lua looks like to run, so for the boar. And you can see that the view comes in. We just call the function. It says, I want to know the fruit nearest to me. And then I get a direction by saying, what direction do I need to go towards that fruit from me? And then if that direction says here, I should bite. And if it's somewhere else, I just return that direction. And this is, Lua is just designed, I mean, you know, it doesn't look that much different than Elixir, but it's just a very simplified kind of domain-specific language that you can expose to your users. Coyote is pretty much exactly the same thing. But it ignores what's nearest and looks for just what's the biggest, bestest fruit out on the board. And thank you very much. I want to give a big thanks to HCA Healthcare, where I work, and the Project Waterpark team, which gave me all my Elixir chops. And thank you to GigCityElixir for putting on this conference and giving us an opportunity to talk. It's been really awesome, and I truly appreciate it. Thank you.